Good day. In this video, we are going to do question 1E of the exemplar of the new level 1 algebra standard called Demonstrate Mathematical Reasoning, paper number 91947, and the paper in short is going to be 1.4. This is an exemplar, so you have not watched video 1, 2, 3, 4, please do so. And this is the 5th video, and this is an excellent question. And without further ado, let's try to solve this. Okay, so this is a typical algebra question. Okay, the question is, prove that the difference between the squares of any two consecutive integers is equal to the sum of this integer. So we're going to let the two integers be n, and the next integer will be n plus 1. Because if it is 5, it's going to be 6. If 7 becomes 8. So that's why the first integer is n, the second integer is n plus 1. So now we need to know that the sum of the integers, so n plus 1, and that is equal to 2n plus 1. Okay, so we need to prove that the difference between the squares of any two consecutive integers. So if this is bigger, so n plus 1 squared minus the second integer squared, okay, the difference between the squares of the two numbers. So this is the square of the first integer minus the square of the second integer, or the other way around, square of the second integer minus the square of the first integer, and we need to prove that that is also equals to 2n plus 1. Then we have done our job. So to do that, we need to expand n plus 1 squared. So we're going to do the grid. I'm not going to do the grid in this video because it's time consuming. So we're just going to do straight away. N plus 1 squared is the same as n plus 1, and that becomes minus n squared. So we expand this part, is going to be n squared plus n plus 1, and then we still minus the second part is minus n squared. Simplify this part, is going to be n squared plus 2n plus 1 minus n squared. So now you have the like term, n squared minus n squared, they will cancel out, so there's nothing left. So the answer is 2n plus 1, which is what we have proved earlier. So we have proved that the difference between the two squares of two consecutive integers, so that part here, okay, the difference between two squares of any two consecutive integers is equal to the sum of the two integers. So we're going to add the two sums. So both of that give you 2n plus 1. So we have proved that that equation is right, and that is an excellence in this paper. So I'll see you in question 2 in the next video for 2a. Cheers everyone, and have a great day.